Okay, so in this next mini lecture, I just want you guys to know how to draw the different monomers for each of our macromolecules. So we're going to learn how to draw glucose, a monosaccharide. We're going to learn how to draw the molecular structure of an amino acid. We will also learn how to draw the molecular structure of a nucleotide, all right, a monomer of nucleic acids. And we're going to learn how to identify molecular structures of lipids. Okay, so let's start off easy. We'll start off with glucose. Okay, now I know that some of you guys may remember that glucose has the molecular formula C6H12O6. Okay, so let's get some different colors here, black and blue. All right, so let's start off by drawing an oxygen. Right here, that circle is oxygen, and oxygen is connected to 1, 2, 3, 4, 5 carbons in a ring, and oxygen there sits off on the shoulder. So let's label this carbon number 1, number 2, number 3, number 4, number 5. Okay, but how many carbons is glucose supposed to have? 6. Well, where's carbon number 6? It is off the shoulder of carbon number 5. Okay? Okay, well, that's all well and good, but what about all the oxygens? Well, here's one oxygen here, right? Okay, well, there is an oxygen right there as part of a hydroxyl group. There is part of a hydroxyl group. Hydroxyl group. Hydroxyl group. Notice that I've written here like HO rather than O, to indicate that the oxygen is bonded to the carbon, and then off of carbon number 6. Okay, so how many oxygens do we have? 1, 2, 3, 4, 5, 6. Okay, so we've got 6 carbons, 6 oxygens. How many hydrogens? Well, 1, and then 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, so satisfying the 4 covalent bond rule for each carbon, we can basically fill up the rest of these carbons with hydrogens. Okay, well, that's kind of like the really complicated way of drawing a glucose molecule. If I ever draw glucose, I might just draw it like that, and then you guys will know that I have drawn a glucose. All right, now how do we get 2 glucoses to come together? Well, if we have an OH group here on 1, and I'm just drawing the simplified form of this here, and if I have another glucose molecule here, and there's another hydroxyl group like we've got over here, right? Do we see an opportunity for water to be lost? Yes. And so now we have created a glycosidic bond. That's the name of this type of bond between these 2 glucose monomers. Now, this monosaccharide of glucose and this monosaccharide of glucose have come together to form maltose, a disaccharide.